The curve C has equation given. The following diagram shows C with the maximum point at A. Question A. Use implicit differentiation to show that dy over dx is equal to this. So we need to differentiate each term on both sides with respect to x. And it becomes, for x squared, derivative with respect to x becomes just 8x plus y squared derivative, but y is some unknown function of x, and we should apply chain rule, and it says that some function to the power n derivative is n multiplied by this function to the power n minus 1 and multiplied by this function derivative. So y squared derivative becomes 2y multiplied by dy over dx plus 2y dy over dx minus 24x derivative is just negative 24 plus 4 dy over dx plus 20 derivative is 0 because it's a constant, and is 0 because derivative of 0 is also 0. And we need just solve for dy over dx, and we can notice that we can divide each term by 2, and we can factor out dy over dx to get dy over dx multiplied by y plus 2 is 12 minus 4x, and finally dy over dx is, we can factor out 4 to get 4 multiplied by 3 minus x divided by y plus 2 as required. The next, hence determines the domain of C. What is the domain? It's possible values of x, and we can see from given graph that possible values of x are in between vertical tangents, and we know that dy over dx gives us gradient of a tangent, and tangent to be vertical there must be division by 0. So vertical tangents are where y is negative 2, and to find x coordinates we should consider y is negative 2 and substitute negative 2 for y into a given equation, and we get that it becomes 4x squared plus y squared, it's 4 minus 24x minus 8 plus 20 is 0. It becomes 4x squared minus 24x plus 16 is 0, and we can divide by 4, and using discriminant b squared minus 4ac and it's 20, and roots are minus b plus minus root of d, it's 4 times 5, so it's 2 times root of 5 divided by 2a, just 2, so it becomes 3 plus minus root of 5, and we can see that a is 5, a is positive integer, so a is 5. The next, find the coordinates of a, and a is a maximum point, and to be a maximum or minimum it's a point where there is a horizontal tangent, and it means that the dy over dx or derivative is 0, and it's clear as it's where x is 3, so x coordinate of a is 3, and again substituting 3 for x, we get that it becomes 4 times 9 36 plus y squared minus 72 plus 4y plus 20 is 0, y squared plus 4y, it's negative 36 plus 20 minus 16 is 0, discriminant b squared 16 minus 4ac, so finally it's 16 times 5, and y is minus b plus minus root of d, so it's 4 times root of 5 over 2a, so it's negative 2 plus minus 2 times root of 5, but it's clear that y coordinate of a is positive, so y coordinate of a is negative 2 plus 2 times root of 5. So it's negative 2 plus 2 times root of 5. It will be required. The next, a line y is mx is a tangent to c where m is integer. Find the possible values of m, and points of intersection arise from what? Simultaneous equations. And we should consider simultaneous equations, and y is mx, so we can just substitute mx for y in the given equation. So mx for y to get 4x squared plus m squared x squared minus 24x plus 4 times m x plus 20 is 0. It's D. Let's check. Y is mx. And it becomes 4 plus m squared multiplied by x squared plus 4m minus 24 and multiplied by x plus 20 is 0. And we need that y is mx to be a tangent, and tangent, it means what? There is only one point of intersection, and we can see that it's quadratic, and there must be only one solution, and it means what? Discriminant should be 0. So we should consider discriminant b squared 4m minus 24 squared minus 4ac and it must be 0. We can factor out 4 here, and it arises as 4 squared, so it's 16 multiplied by m minus 6 squared minus 4 times 5 times 4 plus m squared is 0, and we can divide by 16 and let expand to get m squared minus 12 m plus 36 minus 20 minus 5m squared is 0, and it becomes minus 4m squared minus 12m plus 16 is 0, and let's divide by negative 4. And it is given that the values of m are integers, so you may try some product rule or factorization. I will use discriminant again. Discriminant b squared minus 4ac, it's 25. So roots are minus b plus minus root of d over 2a, and when it's there is minus, it's negative 4, and when it's plus, it's 1. The line y is negative for x, and you can see that negative for x, it's one of values of m. Touch C at point B. Find yb, the y coordinate of b. So again, we need the point of intersection of the line y is negative for x and given curve, so should consider simultaneous equations, and again just substituting negative 4x for y, y is negative 4x. We get that it becomes 4x squared plus 16x squared minus 24x minus 16x plus 20 is 0. And it becomes 20x squared minus 40x plus 20 is 0. And it becomes x squared minus 2x plus 1 is 0. And you can see that it's a perfect square, so x minus 1 is 0 squared, so x is 1. And substituting 1 for x, actually we can substitute into this, but it will be simpler into this because it's a point on both the line and the curve. So you can see that when x is 1, y is negative 4. So x of b is 1, y of b is negative 4 times 1 is negative 4. It looks like this tangent, and point B is somewhere here, so that y is negative 4. The next, the region bounded by the curve C, the y-axis and the lines, the y is y A and y is yb is rotated by 360 degrees about the y-axis to form a solid of revolution. Find the volume of the solid formed. We know that volume of revolution, it's what pi, limits, and what region is it? It's between, it's this one, and is rotated about the y-axis, and the formula is pi, and limits on y-axis, we can see that it's from negative 4 to negative 2 plus 2 times root of 5, and it's inverse function squared dx. This formula is given in a data booklet, or it's the same as x in terms of y squared dy, and we can solve this for x, and you can use discriminant and solve for x. So it becomes 4x squared minus 24x plus y squared plus 4y plus 20, but I want to complete a square to get 4 multiplied by x squared minus 6x, and it becomes x minus 3 squared minus 9. So finally it's 4 multiplied by x minus 3 squared minus 4 times 9, it's 36, and plus 20, so it becomes minus 16, and plus y squared plus 4y is 0, and it becomes x minus 3 squared, it's minus minus plus and over 4, hence x minus 3 is plus minus square root of the right hand side, so x becomes 3 plus minus, or let me show it clearly, that it becomes 4 times x minus 3 squared is negative y squared minus 4y plus 16, hence x minus 3 squared becomes over 4, hence x minus 3 over 4 then square root becomes just 2 here and the square root here, and finally x becomes 3 plus minus, and in general it's plus minus square root 1 over 2, so 0.5, and the square root of negative y squared minus 4y plus 16. But what should we choose? Plus or minus? And we can see that there is a point 1, negative 4, because this curve, this part of this curve is rotated, so there must be a point 1, negative 4. So let's check 1, negative 4, substituting 1 for x, and negative 4 for y, it becomes negative 16 plus 16 plus 16. You can see it's 4, 2, and to get 1 it's minus. So finally x is 3 minus 0.5 square root and it becomes pi integral, and this squared dy. And using a calculator, you can see that it's integral from negative 4 to negative 2 plus 2 times root of 5, 3 minus 0.5 root negative x squared minus 4x plus 16 squared dx, and then just multiplied by pi, and we get finally that it's 29.7 to 3 significant figures. And that's all for this question.